should I use it for this talk?
So I can actually put the batteries in if you would like to use it.
I might not need a laser pointer. I don't. Well,
Okay.
I don't think I do.
Okay, if you do, call me.
All right, I'll
Okay,
yell.
So let's
Okay, thank you for coming. I thought before I start and tell you what I'm going to talk about, I will tell you what I'm not going to talk about. This, of course, is a very famous book written by an also very famous cosmologist that anyone in the field of cosmology knows quite well. Lawrence Krauss, he wrote a book called The Physics of Star Trek. By the way, is my microphone working? Can you hear me? Okay, good. This talk is not going to be the physics of Star Trek. And I mean that in two different senses. First of all, I want to concentrate a bit more on written science fiction than TV and movie science fiction, mostly because I think the scientific ideas that you encounter in written science fiction are much more interesting, and written science fiction incorporates science in I think, a much richer and more important way than do movies and television. And secondly, The Physics of Star Trek is a classic kind of book that I think a lot of people have read and a lot of people have written, where you go through each of the ideas of science fiction, faster than light travel, time travel, and you kind of explain what their scientific validity is. And in most cases, there isn't any, so it's a very short book. But many of you, most of you are in the physics department. I don't need to tell you what the issues are with time travel. If there weren't any, I would have shown it for yesterday. But it's not something that's, I think, is interesting. What I want to talk about is a slightly different subject, and that is the way that ideas get incorporated into science fiction and in science, and the ground rules for doing that. This idea came to me when I first started writing science fiction. I came to the field relatively late, in the sense that I was an established scientist first, and so I started trying to get published around the year 2000 or so. And every morning, as Louis knows, the Ohio State Astronomy Department has a coffee where they go look at the papers on the archive and go over them and talk about them. And I think a lot of us do that on an individual basis. I go over the papers in the archive every morning, and I think, well, that's interesting, and that's interesting. Could I incorporate that into a paper? Could I do something with that idea? And then I found myself saying, well, that's not a very good idea, but, I could write a science fiction story about it. And I realized that in some ways, trying to evaluate what makes a good idea for a story and what makes a good idea for a physics paper are not the same thing. I mean, cosmology is not science fiction, despite what you've heard. But in fact, there are some interesting similarities. So what I want to talk about are first of all, the ground rules for introducing new ideas, both into science and into science fiction. And I think, as scientists, we don't often take a step back and think about our own field. Usually that's a good thing, because you don't want to get caught up in knots of philosophy. But I think it's interesting to step back and ask, how do I decide what makes a good idea in science, and how do I decide what makes a good idea in science fiction? I want to talk a little bit about the predictive power of science, which we hope it has, versus the predictive power of science fiction. I want to talk about how ideas get presented in the two fields. And then finally, I'll finish with a note that might be of interest to some of you is, should scientists try to write science fiction? Do we have a special ability in that regard, or is it something that's best left to other people? And of course, by science here, I will mean theoretical physics. Mostly because that's what I do for a living, and also because I think that's the area of physics which is closest to science fiction, and you can take that any way you like. So I would argue that both science fiction writing and theoretical physics are something that I would call disciplined daydreaming. That is, you're trying to come up with new ideas. You're trying to develop something beyond what is already known, but you're doing it within tightly constrained boundaries. You can't just arbitrarily speculate either in science or in science fiction. And so let's look at science first, because I think that's something that'll be a little bit more familiar to you. There's many different kinds of theoretical physics, of course. You could do data analysis, which is the closest to experimental physics of any of the theoretical physics activities, where you're looking at data and just trying to understand what it's telling you. You can compare your models with the data, and then getting kind of further away from data and more toward pure speculation, you could do model building. You can try to put together a model for some physical system. And finally, what I'll call just the what-if paper, a style that was very popular back when I was at the University of Chicago with Rocky Kolb and Mike Turner. That is, you ask a question, what if this were the case? What if the constants of nature were different early on in time? What if there was an asymmetry between the neutrino and antineutrino? And this is really the closest of the kinds of theoretical physics you could do to the process of doing science fiction, and it has actually often yielded the most interesting results. So what if the speed of light were constant in all frames of reference? If you had thought of that idea in 1900, you could have published ahead of this guy. That, of course, gives us special relativity. What if the energies in a black body radiation are just discrete multiples of the frequency? If you'd thought of that idea before 1900, you'd have a constant named after you. That, of course, is Planck's constant. And a more recent idea, which is due to Alan Guth and Andre Linde and a few others, is what if the universe entered a phase of exponential expansion at early times? That can be worked out and gives you the theory of inflation. Now, there are still constraints, of course, on what you can do in terms of a new idea in theoretical physics. The acid test, of course, is that it has to be consistent with known experimental results. This is something we have to beat into our students. Not even senior theorists always obey this rule, but in general, you know, if it violates what we know, what we observe, it's not a good theory, and you shouldn't be messing around with it, all right? But it's, I think, a more subtle point, which is true, and you know, we don't like to admit this, but it's really true, is that in some sense it has to fit into the pre-existing framework of physics that's already there, the pre-existing theoretical framework. So we often present the idea that quantum mechanics and general relativity were these fantastic revolutions that overturned everything that came before them. Of course, they not only didn't do that, because in the corresponding limits they reduced to classical physics, but they didn't overturn any of the language or the tools that we use in physics. So quantum mechanics, of course, makes use of energy and momentum and position. It didn't throw those ideas away. And the same thing for relativity. We still use a coordinate system. We just modify how the coordinate system can be used. And I think this fact is most clear if, like me, you're a department chair and people want to send you their theories of the universe. Or if you're a cosmologist and people want to send you their theories of the universe. And if you're both, you get a lot of theories of the universe sent to you. So the problem with these papers that I get, which are, you know, I have a new theory, could you, and they're almost always retired engineers. I don't know why, but they usually are. And I don't know why, but the problem with these papers is that I can't write back to them and say, this equation is wrong or that equation is wrong, because they're constructed so far outside the framework of physics that I can't connect them to anything that I do. You know, they'll invent new terms and then new equations with the new expressions, and there's never any grounding in pre-existing physics. So the people who argue, you know, and then they complain that we're all stodgy and stuck in the mud, we don't accept new ideas. Well, at some level, they're right. We don't ever just throw out, not since the time of Isaac Newton, we don't throw out everything that's come before us. Our new ideas fit into the pre-existing structure that's already there. On the other hand, and again, this is what's kind of hard to teach graduate students, and sometimes it's hard to do it yourself, what you come up with still has to go beyond what is already known. So your idea has to be, you know, close enough to what we know already to be acceptable, but far enough outside what's already known to be original. And so a theoretical physicist is constantly trying to hit this sweet spot here, right? If you don't do anything new, it's boring, and if you go a little too far out, you become a crackpot. And you're constantly trying to you know, be outside of what's already known, but not so far outside that you're relegated to the crazy category. My advisor, Mike Turner, came up with a very famous statement. He said you could only invoke the tooth fairy once. And what he meant by that is that in a new paper, you could introduce one really wild, crazy idea, but if you start multiplying it to fix your theory up, very soon you're removed from anything that could be considered theoretical physics. You're in the crazy category. And I think what's interesting about this is that the fact that we can't really invoke multiple tooth fairies kind of sets a speed limit on how far past physics can progress. It really can't progress much faster than the experimental data that's coming in. So to give you an example of that, I'm going to go to science fiction pretty soon. Imagine that I have a time machine, which is reasonable, and I decide to go back to the late 19th century. And if I were a normal person, I would get all the stock quotes and find out where the good railroad stocks were, and I would buy up all the right stocks, and I'd be filthy rich. But since I'm a scientist instead of a normal person, I decide what I really want is to take one of the ideas of 20th century physics and invent it in the 19th century and get credit for it. Unfortunately, I can't remember very well any of these things, but the one thing I can remember is how the sun shines. So I go to the physics department at MIT, in the late 19th century and I say, look, you don't know me, but I am a brilliant physicist and I have a theory of how the sun shines. And they'll say, well, that's a big mystery because, we think it's gravitational energy, but it can only power the sun for about 1 million years. You say, no, this is all wrong. The sun is powered by nuclear fusion. They say, what's that? Well, in the center of the nucleus. What's a nucleus? Well, okay, there's atoms, right? Everything's made up of atoms. And then what are those? Well, there's like little nuclei, and then there's electrons spinning around them. And then the nuclei can actually fuse. And oh, by the way, energy is not conserved the way you think it is. And then by that point, I would be thrown out of the office because am trying to introduce too many ideas that just aren't, the world wasn't ready for yet. Now, I think there's actually an interesting counterexample today, and I don't think it's entirely played out. We don't know where it's going. And of course, that's string theory, which is really far ahead of the observations. And I'm not going to say anything one way or the other because I don't want half the building to jump on my back. But it's interesting. I'm an agnostic when it comes to string theory. I'm neither a fan nor an enemy. I'm just watching and waiting to see what's going to happen with string theory. Now, rather surprisingly, I think there's some similarities to this model in the world of science fiction. First of all, much, but not all of science fiction is also based on this what-if model. So what if our evolution had been guided by superior beings? That simple idea can build an entire novel, 2001, A Space Odyssey. And if you haven't seen the novel, you've probably seen the movie. And I don't understand the ending, but don't worry about that. What if, now there's some more obscure novels, I think they're even more pure example of this. What if all living things on the planet suddenly experienced an increase in their intelligence? This was exploited by Poul Anderson in a book called Brainwave. So everybody on the planet becomes a genius, which you might think is really wonderful, but suddenly all the farm animals attain human intelligence and decide they don't actually want to be eaten anymore, and the pigs are the smartest of them all, and they're the most dangerous. What if our dreams could change reality? That's a very famous book by Ursula K. Le Guin called The Lathe of Heaven. Now, it might seem from an outside perspective that science fiction just gives you carte blanche to make any kind of speculation you want, but that really isn't true. There are still kind of rules that go into science fiction, and one of them is that the new ideas have to be plausible. Now, obviously, not every science fiction story is pure science. It's not a rigorous development of an idea. If I find myself developing that in a science fiction story, I submit it to physical review because it's science, right? But the ideas have to be plausible. Even if they're not science, they have to make use of the framework of science, the kind of mindset of science. And you'll see that in a lot of fiction. When it gets where it kind of drifts away is in something like Star Trek, where they have something called technobabble, where they have to jettison the ion pod, where they throw they can throw in a lot of terms, and after a while, if you're a scientist, you realize they don't know what they're talking about. But a lot of written science fiction really does a much better job of staying within a plausible framework. In science fiction, as opposed to fantasy, only naturalistic explanations are allowed. So if I come up with a story about a virus that's it's kind of like the rabies virus, so it's transmitted in saliva, and it causes photophobia, and it causes iron deficiency. So people who have this virus have to drink blood to keep their iron levels up, and they can't go out in the sun because they're very sensitive to the light. That's a legitimate science fiction story. But if I say Vladimir was a vampire, that's not science fiction. That's fantasy. And new ideas are usually introduced and rationalized in some way in a science fiction story. So when you bring in an idea, there's normally some attempt to justify it or to rationalize it to make it seem like it's reasonable, like you could plausibly believe it. But there's a counter example of that, and that is that some very implausible ideas have been used so many times that they become part of the fabric of the culture of science fiction, and when they're brought in nowadays, you don't even bother to explain them. So, for example, I teach a course with an English professor on science and science fiction, and the first thing we read is The Time Machine by H.G. Wells, because it's in some ways the very first science fiction novel. And the very first chapter has a multi-page explanation of how time is the fourth dimension, and you could travel in the fourth dimension just like you could travel in the other three, and you could actually go forwards and backwards in time. And when I read that, again, after having read it the first time in 6th grade for this class, I thought, well, that's really interesting. He obviously, was familiar with Einstein's theory of relativity, and this influenced the book, and that's why we have The Time Machine. It turns out the time machine was written 10 years before Einstein's theory of relativity. So maybe, draw your own conclusions. But nowadays, we would simply say, I wrote a time machine book, and you just have a time machine. You say he jumped into his time machine and he was off. Or, he was back in the 23rd century. You don't even tell them it's a time machine. You just have people traveling through time. The other example of this is faster than light travel, which, as we all know, is impossible, but it kind of ruins all the best stories about galactic empires. If you read Isaac Asimov's Foundation series, which was written in the early 40s, he has a long, tedious explanation of how faster than light travel works through hyperspace, which isn't really normal space, but it's kind of bent. He goes into quite a bit of detail. A modern person writing a book like that would just say he hopped into his translite ship and off he went. I mean, we've all seen Star Wars. You know how it's done. You just bang on the thing and it works. And the other example of how I think science fiction parallels science is that many of the strongest stories and novels, the ones that really stick in your mind 40 years after you read them, are the ones that do invoke the tooth fairy once. The idea stories where there's just a really brilliant, slight difference, a clever idea introduced, and an entire novel or an entire story is based on that. So I would argue that just like science, there's a kind of level of layers in fiction where if you make no assumptions about, you don't change anything about reality, you're dealing with mainstream fiction. If you just, have no holds barred, you're out here in the world of fantasy, and that puts science fiction somewhere in the middle, where you need to extrapolate beyond what's already known, but you're much more constrained about what you're allowed to say and what you're allowed to conclude in terms of the structure of the ideas you introduce. Now, one essential characteristic of new ideas in physics is their predictive character, and I'm not even going to say anything about that. All right, that's a given. If physics can't predict things, it's not physics anymore, and we should all turn in our union cards. Is science fiction similarly predictive? Does science fiction predict the future? Well, there's some particularly impressive predictions that were made. Jules Verne in 1865, in his book about the first moon landing, predicted that the first moon landing would be conducted by Americans. This was at a time when the U.S. was a backwater compared to Europe, and certainly scientifically was a third-rate power. It would launch with a 3-man crew, and it would launch from a point in Florida to take advantage of the equatorial motion of the Earth. He even had the various cities engage in a competition to get the site of the moon launch, and the point in Florida won. Now, the only mistake in his book is he has it launching from the west coast of Florida, not the east coast. So I think we should criticize him on that. The other thing is that there's actually a budget given in the novel, how much money they had to spend on the project. Jules Verne is, brilliant, but really boring in some places. So he goes into, as they say, too much information. And so he gives you the budget for the project, and if you take that budget and extrapolate it forward to 1960s dollars, it's actually pretty close to what was actually spent. Many authors predicted nuclear power in the 30s and 40s. There's a very famous story. Cleve Cartmel wrote a story for Astounding, which was the precursor of Analog, which is the place I mostly have published, in which he described an atomic bomb, and the editor's offices were visited by U.S. security to find out if there had been a leak. It turned out there hadn't been a leak, but the editor promised not to say anything about it until after the war, and then, of course, he was thrilled that he had been raided by the FBI. Arthur C. Clarke famously predicted communication satellites, but these were, of course, this was in a nonfiction article, although, of course, he later introduced a lot of very clever ideas in his fiction. But consider these predictions. I mean, I think many of us are familiar with these. Science fiction predicted that we would have nuclear power that would give us electricity that was too cheap to meter, right? It would just be free. It did not predict that we'd have long-distance phone calls that were too cheap to meter. Science fiction predicted that one day everyone would be connected to a large central computer. This is a common theme in a lot of 1950s fiction about computers. Nobody predicted that everyone would have their own computer, although we're maybe evolving toward the science fictional ideal with the internet. Maybe we are, in fact, all evolving toward one central computer called Google. Science fiction predicted the population bomb, but they never predicted the Social Security bomb. And we were also promised robots as cooks and maids, and I have not gotten my robot cook or my maid yet. Nobody predicted that they'd be auto workers and drive other people out of business. So there are a lot of other famous predictions that have never come true. So we haven't colonized the solar system yet. In most science fiction books, we should have been there by now. We haven't contacted any extraterrestrial life. We don't have personal autogyros or helicopters or rocket packs or airplanes. We're still driving cars. And we don't have death rays. That's probably a good thing. But the others I kind of would have liked to have seen. And in fact, I would argue that the fact that a lot of, in a certain generation, which is probably about my generation, maybe even a little bit older, there's a kind of, well, let me mention one other thing first, and then we'll go to that. This is, you can't read these captions, so I'm going to read them for you. This is from an article that appeared in about 1950, and I can't remember if it's Popular Mechanics or Popular Science, but you could look it up on the internet, and it's a great article called The World of the Year 2000. So in 1950, they were going to predict what was going to be the way that we were going to live in the year 2000. And I'll read you this caption. This is a woman spraying a hose on her couch, and it says, because everything in her home is waterproof, the housewife of 2000 can do her daily cleaning with a hose. Okay. This one says, housewives in 50 years may wash dirty dishes right down the drain. Cheap plastic would melt in hot water. Now, that actually does happen, and we've achieved that, but it's not used as a method of cleaning dishes. And this says, already available is electronic stove, which can prepare meals in 75 seconds. It may replace present ranges. So there's your microwave, and she's about to put that in. And any of you who've heated up food in a microwave knows that it has not replaced the oven, although I know they're doing research to try to make that work. I think one of the most interesting things about this, the thing that's most jarring about this, I think, is not the hose or the melted plastic. It's the use of the word housewife, which now seems like, whoa, housewife, that's weird. That didn't come true. And I think that's to go down a little side road here, science fiction has been much worse at predicting sociological developments than it has at predicting scientific developments. And I think there's an obvious reason for that, is that people don't really want to be dragged too far out of their comfort zone when they read a science fiction novel. And that's why a lot of 1950s science fiction basically is people from the 1950s, colonizing the galaxy in the year 2300. Science fiction, for all of its daring, often doesn't dare to imagine, or maybe people have more difficulty imagining a different social arrangement than they do from imagining a different physical arrangement. But what I was going to say is that I think that the fact that all these predictions didn't come true has led to a kind of retro nostalgia. That is, a kind of sadness over all these things we were promised as kids that never happened. The Smithsonian actually had a traveling exhibit on this called Yesterday's Tomorrows, Past Visions of the American Future. And Daniel Wilson wrote a book called Where's My Jetpack, which I always want to say, where's my jetpack, dude? But it's basically what he kind of goes through all the things that, well, it says a guide to the amazing science fiction future that never arrived. And I think the largest example of retro nostalgia, and some of you I think have probably seen this in person, is this. How many people have seen this in person? It's Disney World, the one in Florida, not the one in California, but they're the same. So, of course, Disney had the World of Tomorrow, which they built in the 1950s in California, and by the time the 1970s showed up, it was looking pretty old. So they came up with a new World of Tomorrow that was all white and gleamy. And by the time the 1990s came around, that was looking kind of old. So they finally threw in the towel and decided that instead of presenting the World of Tomorrow, they would present yesterday's World of Tomorrow with lots of brushed steel and rivets and nuts and bolts. I would encourage you just to visit this at some point if you're interested in this kind of stuff at all, because it's really a masterful illustration of a world that never came to be. It existed only in the imagination of 1950 science fiction writers. So I'll now, give you the answer to the quiz question. Science fiction is not predictive except accidentally, okay? Because the function of science fiction is not to predict the future, it's to entertain. And the ideas that people introduce are really there to serve that purpose. So, you'll sometimes see people call science fiction the literature of ideas, but in fact, ideas are secondary to the main purpose of science fiction. The primary purpose is to tell an entertaining story. So to give you an example of this contrast, there's a joke I always tell my physics class when I teach quantum mechanics to the undergraduates. I say, well, quantum mechanics has never been unified with general relativity. If you come up with a good idea, let me know, and I'll write the paper for you, and we'll publish it together. But unfortunately, in science fiction, it's the other way around. I have a whole bunch of people come to me and say, well, I have this great idea for a story. Why don't you write the story, and then we'll sign both our names to it. And these are, in fact, identical things. Essentially, in science, the idea is everything, right? The development is secondary, and the writing is really a third, tertiary goal. And that, again, that's something that grad students sometimes don't appreciate. They say, well, you know, I did all the work on this. All my advisor did was give me the idea to work on, and then he just didn't show up for 3 weeks. And how come I don't get all the credit for it? But of course, it's the idea that is the key thing. If you can come up with one great idea a year, you could take off the rest of the year if you're a theoretical physicist. But that'd be a really good idea. In science fiction, really, it's the writing that's primary, and the idea, as important as it is secondary. The exposition of an idea is not a science fiction story. So again, you might say, well, I've got this great idea for a story. You know, there's a world where, well, let me think of an example. There's a world where, I'll give you an example of a story I wrote. There's a world where everybody knows what day they're going to die on, but not the year. So I know I'm going to die on February 3rd. I just don't know what year it's going to be, so obviously I'm extra careful on February 3rd. If I sent that in to an editor, he'd say, well, that sounds like a good idea, now write the story, right? That's not a story. You need characters and a plot to give the reader something to be interested in. The idea is insufficient. Now, there are especially, you know, in the classic Isaac Asimov type, you know, 2-page stories, there are stories that are almost just an idea with nothing else. But even those stories have an element of plot to them. He doesn't just throw an idea out at you and say, hey, that's a clever idea. There's something actually happens. And there's a famous quote by Fred Poole. He said, we need to predict not the car, but the traffic jam. In other words, the interesting thing about science fiction is not the technological development and the scientific development, but how it affects people. And so I would even take that one further. I would say it's not the car or the traffic jam. It's the guy who goes crazy in the traffic jam and gets his axe out and smashes his car up into little pieces. That's an interesting story. The traffic jam by itself isn't interesting. So that's kind of the, you know, I think the key difference between science and science fiction is that really science fiction has to go to something that has a plot in it, it has to entertain, and it has to involve people or the alien equivalent of people. So how are ideas presented? Here there's a big difference between physics or science and science fiction. In science, it's very straightforward. You, first of all, discuss your background and motivation for the project. You discuss the previous work, especially your own. You present your results. You summarize your conclusions. And then you ruin the ending of the story by putting the abstract at the beginning. So you tell everybody at the beginning everything you're going to say. So you ruin the surprise at the end. But that's okay, all right? That's the way we write science papers. What about science fiction? Well, in science fiction, it's not so easy. So let me show you an example of trying to introduce an idea in science fiction. I'm just going to read this very rapidly. Joe Waltham burst into the ship's control room. Klaxons wailed and the neutrino gauges flickered wildly. Billy shouted, the solar neutrino detectors have gone crazy. The sun produces neutrinos in the course of its fusion reactions. 2 protons bind to form deuterium, producing a positron and an electron neutrino. The electron neutrino can escape from the sun's core. Bill rushed over to check the detector feeds. I don't see anything wrong at this end. Now, that is kind of problematic, right? What I'm trying to do is explain why the sun makes neutrinos. So in the middle of this exciting thing, I take some time out to tell you all about nuclear astrophysics, and then I get back to the story. This has a technical term in the writing world. It's called an info dump. And I think one of the interesting things about getting into a new field, you know, when I moved into trying to write science fiction, is that every field has its own cool jargon, and then you can learn all that jargon, and then you can feel superior to all the people who don't know the jargon. So now I'm letting you in on the secret. So this is an info dump, and it's a bad thing. Okay. So let's be more subtle. Let's think about how we can introduce this information into the story without the dreaded info dump. So Joe Waltham burst into the ship's control room. Klaxons wailed and the neutrino gauges flickered wildly. Billy shouted, the solar neutrino detectors have gone crazy. Bill rushed over to check the detector feeds. I don't see anything wrong at this end. He turned to Joe. As you know, Joe, the sun produces neutrinos in the course of its fusion reactions. Yes, said Joe, I know that. And you also know that 2 protons bind to form deuterium, producing a positron and an electron neutrino. Joe nodded. Yes, I know that too, but why are you telling me all these things I already know? Okay. So this, you know, this is the next level up. This is moving from fool's mate in chess to scholar's mate. And this also has a name, and I'm pleased to tell you that it's called the As You Know, Bob. And my name is Bob, so I'm completely pleased with this. So, of course, our neophyte writer has decided to be clever and introduce the information in a conversation, but in a way that is completely unrealistic and also kind of stilted. So the problem here, of course, is that this person knows all this stuff. This is still a legitimate technique for introducing information into a story, but it has to be done much more subtly, and it has to be done in such a way that the reader doesn't notice that it's being done. In other words, it has to be done in a very natural way that advances the plot. So now I'm going to show you, how information can be introduced. I'm going to give you the beginning of one of my stories, not because it's a especially wonderful story, but because I had it on my disk drive, and it's, I own the copyright. The thing is that you have to introduce new information without interrupting the flow of the story. And so the way this is usually done is to kind of dribble the information in and to try to keep the reader so interested that they're begging for an info dump, so that when you finally give them a big chunk of exposition, they're grateful that you gave it to them and they're really excited to get it. So here's the beginning of one of my stories. Jimmy Dyson pushed the bicycle through the sun-baked field behind Betty Krause's house, spraying clouds of dandelion seeds into the air and jostling the precious cargo in the basket mounted on the handlebars. Withered thistles caught on the scratchy wool socks his mom always made him wear, even in the St. Louis summer. Benny, it came yesterday, Jimmy shouted, lifting a brick red box from the basket and waving it in the air. It has Bob Gibson on the cover. Okay, so what do we deduce from this? Well, first of all, the name of the story is Extra Innings. So what's the story going to be about? Baseball. How many people here know who Bob Gibson is? Everyone over the age of my age. Okay, excellent. All right. And how old are these characters? Are they in their 40s maybe, or? Yeah, they're in their 40s. They just don't get out much. No, they're kids. In the story, they're 8th graders, and you know this. There's a couple ways you know. First of all, they're called Benny and Jimmy, which are not adult names. And secondly, this kid he's bicycling. He's not driving the car over to his friend's house. And he's got these scratchy wool socks that his mom always made him wear. Now, the scratchy wool socks don't ever kind of into the rest of the story. We never see the scratchy wool socks again. Their only purpose is to tell you that these are kids, and they're doing what their mom tells them to do. They're not teenagers either. They're kind of kids who are still at the kind of doing what your mom and dad want you to do age, which ends at about 3 as far as I can tell. But, now, in science fiction, I think more than in mainstream literature, it's very important to establish the setting and characters right at the beginning of the story. And the reason is that there's so many possibilities, right? So in a New Yorker kind of short story, you could kind of play around with the setting and be a little cute. But in a science fiction story, you don't know if it's taking place on the Earth or on another planet. You don't know if the protagonist is a human being or a squid-like creature. You don't know if it takes place in the present or, in the dinosaur age or thousands of years in the future. So as hard as it is, you have to kind of get the setting set up in a way that establishes all of these things, but again, without dumping too much information in. Now, you don't have to explain everything immediately, and that's another trick that science fiction writers use to establish interest. So here's the story I was telling you about. My death day is July 18th. This is the beginning of this short story. I spent it this year, as I have every year for the past 10, at home in bed with my wife nearby. I can't afford a private doctor, and I've heard too many iatrogenic horror stories to check into the hospital for the day, so I just lay quietly, imagining all of the different ways it could happen. A sudden squeezing pain in my chest, or maybe a jackhammer headache announcing a burst blood vessel in my brain. Real upper story. It's good. Cheerful. But the thing about the story is that it doesn't explain anything, right? He talks about a death day, and there's something about July 18th, but he doesn't explain what's going on or why he has to be inside that day, or and then as the story goes on, you learn the fact that everybody does know the day they're going to die, and you learn how they found out. But it doesn't get explained at the beginning, and this is okay. There's a kind of an implied contract between a reader and an author in science fiction, that you can introduce weird new terms, you can introduce weird ideas, and you can confuse people a little bit as long as you tie everything up by the end. And if you don't, you get a very angry reader who will never read your stuff again, right? So in science fiction, you have to strike a balance between giving too much information up front, which is boring, and giving too little, which is incomprehensible. Again, you're trying to hit the median where you're introducing enough science fiction to keep people, enough confusion to keep people excited, but not so much that they just give up and say, I haven't got a clue what's going on. And there are stories that are like that. You have not got a clue what's going on, and I usually don't get past the first paragraph of those. In science, all the information goes up front. All terms are defined as soon as they're introduced, and it's okay to be boring, but it's not okay to be incomprehensible. What's interesting is that both of these have the same goal. They're just achieved in different ways. You're trying to get someone to read your paper. In a physics paper, you try to put all the interesting information in an abstract so someone says, wow, that's really interesting. I'm going to read this paper, or at least print it out from the archive and put it on my desk. And in science fiction, you're trying to get someone to keep reading the story, to read all the way to the end. But writing styles are also very different. So in science fiction, I think this is the Chuck Yeager effect. I think some of you are familiar with the Right Stuff, where he talks about how Chuck Yeager had this West Virginia drawl, and he was the greatest test pilot of them all. So pretty soon all the test pilots and all the astronauts developed a West Virginia drawl. Science, I think there's a lot of still influence from the German writing habits. So in science, we aggressively use the passive voice. We qualify everything. We have numerous parenthetical clauses. We have a lot of compound nouns, which I think comes from the German. I once refereed a paper that was so aggressively passive that they made a claim, and it was impossible to tell if they had done it themselves or if they were citing someone else's work. And I queried them and said, you have to explain this. I don't know what the story is. And they came back, and it turned out that, yes, they had done it, but in such a way that you couldn't tell they had done it. In science fiction, you're taught to avoid passive constructions at all costs. This is a big no-no in all writing if you want to keep people entertained. Emphasizing vivid verbs and adjectives, avoiding adverbs. A lot of this is just the style of the day, and it wasn't always like this. So to give you an example of what I mean by that, let's take the opening line of this paper about Bob Gibson and rewrite it as a physics paper. A bicycle was pushed by Jimmy Dyson through the sun-baked Benny Krausehaus field. Thus, dandelion seeds were dispersed into the air, and the cargo in the handlebar-mounted basket was somewhat jostled. Thistles, fairly withered, see discussion in part 2 below, were caught on Dyson socks. The story takes place in St. Louis in the summer. So you see, the information is all there, but it's not presented in a way that maybe a reader would like to see it. And I should say, I'm giving you these preferred writing styles in science fiction. They've changed with time. So, for example, it's considered very bad form now. When people first start to write, they often think that you shouldn't repeat the word said. He said, she said, he said. So they say he shouted, he whispered, he mumbled. That's actually considered a very bad writing style nowadays in the fiction world. It's better to just use said, or even to say nothing, to just have lines of quotes one after the other. That's, again, a stylistic preference of the modern age. It was not always like that. So here's a line from one of the Wizard of Oz books. The king grumbled, said Dorothy earnestly, said Everett with much dignity, cried Bellina with a cluck. She's a chicken, by the way. Went for a laugh, said Dorothy. Finally, someone just says something. And then she answers, and she has to answer thoughtfully. So these are the kind of things that an editor would strike nowadays, but which were considered perfectly okay 100 years ago. So let me finish with my last topic, which is, do scientists have an advantage in writing science fiction? Well, there certainly are many science fiction authors who have a science background. So I think you've heard of some of these people. Isaac Asimov got a PhD in chemistry, and in fact he was a professor at Boston College or Boston University for many years. Robert Heinlein did graduate work in physics. Arthur C. Clarke had his bachelor's in physics and math. Larry Niven has a bachelor's in math. And Michael Crichton, actually, of all the people, he wrote The Andromeda Strain and Jurassic Park. Of all the people on this list, he actually has the biggest scientific credentials. He did postdoctoral biomedical research. So he got past the doctoral degree, was a postdoc. I think he often doesn't get listed in lists like this because, first of all, many science fiction purists don't consider his stuff to be real science fiction. And, of course, physicists don't consider biomedical research to be real science. So. And there also are scientists who've dabbled in science fiction. Some of them you may know. John Kramer at the University of Washington wrote a novel. Don Clayton wrote a couple novels. Craig Greeler wrote a novel. And I would consider myself probably a dabbler because I've written a lot of short stories, but I've never written a book. There only are a few people who really established careers in both fields. In fact, I would say there's only one Nobel Prize class scientist. And by that I mean someone who either won or should have won the Nobel Prize, in this case should have won the Nobel Prize, who also had a very major influence on the field of science fiction. And when he died, there were obituaries in both the science journals and in the science fiction websites. So anybody know who that is? Fred Hoyle. It's Fred Hoyle. inventor of the steady state model, which didn't work out so well, but maybe it was just science fiction. So he was an author of quite a few science fiction novels and a very, very important figure in astrophysics. The only other person who comes to mind, who you mentioned earlier, Gregory Benford, who has is not in the same scientific class as Fred Hoyle, but might be a better writer than him. He just retired from UC Irvine, but he's has written a lot of science fiction novels along the way. And so why is that? Well, I don't think it's a big surprise. It's like asking, why aren't there more baseball players who play football in the off season, or people who are physics professors, but then they get the summer off so they can go play for the White Sox. I mean, this is you got some extra time, or you take it's because most people are better in one field or the other, and they naturally gravitate more for the thing they're better at, and it's hard to maintain a dual career like that. Do scientists have an advantage in writing science fiction? I would say yes, but actually not the advantages that everybody thinks. The advantage everybody thinks is the science, so you could write a story about your science, right? That's great. Why don't you do that? And people who are not scientists kind of look upon scientists and say, well, that's, it's not fair. You know all the science. I've actually found it harder to write science fiction about my own field. That baseball story, which is like my sixth story, was the first time I tried to write about cosmology. And the reason is when you're trying to write about your own field, you immediately see all the implausibilities. You know that can't possibly be true. And I know that dark matter isn't made up of, extra physics papers floating in orbit or something. I mean, maybe it is, but I mean, the problem is that you're much pickier about your own research field. So when I started writing, I've got a short story that I just wrote about neuroscience. I don't know anything about neuroscience. I mean, I just accept what I read in the papers. It's actually harder, I think, to write about your own research. And the other thing that's hard to break out of is that the styles are so diametrically opposed that if you sit down to write a science fiction story, you have to kind of bang yourself in the head and say, I am not writing a physics paper. I'm not writing a physics paper. That's true even if you decide to write a popular science article. If you're going to write an article for Scientific American, forget it. No, don't use the word however. Don't use the word thus. And, start in the middle of the story and have some flashy pictures. It's not the same style. And it's still possible to do it. And most people who make their way into science are good writers, but you just have to kind of consciously disengage from one style of writing and adopt a completely different style of writing. There are some significant advantages. One, I think, is very important, is that most scientists have basic writing skills. I mean, you've written scientific papers. If you don't, if you're a grad student and you haven't developed this, it's time to work on it. Writing is, I think, an unsung component to a successful career. And when I have high school students come in to ask me what they should be, studying if they want to major in physics in college, I say, well, take the most advanced math you can, the most advanced physics you can, and the most advanced English you can. And they kind of roll their eyes like I told them to, hang in a dungeon for 10 years. But it's, it is true that if you're a good writer, it really helps you. If you can write quickly and accurately and clearly, you don't have to be a brilliant writer. It helps you. And so I think most scientists have basic writing skills. And as I've said, scientists have already mastered the idea of extrapolating new ideas from known facts. Now, it's a different arena, a different set of ground rules, but it's still a similar kind of process. And finally, and this is a rather minor point, but I think important, you can be much more realistic if you're going to write a story about doing science. Now, not all science fiction, in fact, most science fiction does not star scientists doing science. But, for example, Gregory Benford's novel Timescape, which is, I think, his best novel, does exactly that. It takes place in Cambridge and at UC Irvine. No, UC San Diego. Yeah, UC San Diego. And he really captures the whole process of doing science, the way that scientists do it, in a very accurate way because, of course, he was immersed in it himself. A lot of science fiction writers who are not scientists have trouble with that, and they mess up really silly details. So, for example, I read an award-winning story where they were talking about a scientist. Instead of giving talks on his papers, he was going around giving speeches on his papers. And any scientist would have caught that and said, no, wrong word. But this person didn't know any scientists, and so their scientists gave talks. So let me close here. Well, let me not close. Let me say one more thing. You want to try it? Well, I think that the science fiction publishing world, like all publishing worlds, is in deep peril, but it still hasn't fallen apart completely. There are still, if you want to write short stories, it's one of the few outlets that still reads unsolicited manuscripts and will publish them if they're good. So the big, Analog Magazine where I publish is the hard science fiction magazine. They're the ones that want very accurate science. But even Nature publishes 1,000-word short stories with every issue at the end of the issue. So if you pull up an issue of Nature and look in the back, they've got a 1,000-word story, and they accept unsolicited stories. If you want to write a novel, you have to find an agent, which means that they just move the gatekeeper one step forward. So you have to send it out to 100 agents and find someone who's interested. But it's also possible to kind of get started in short stories and establish a record there so you're more plausible. But one difference, which is very annoying, is that credentials and previous performance don't count for very much, unfortunately, in the science. And, in the science world, you can kind of coast for a few years on previous performance, or a decade or 2, 3, 5. But in science fiction, you're pretty much only as good as the last thing you wrote. So if you said, if you're a famous writer, the editors say that they reject stories by famous writers all the time, and I believe they do. If you're, you could be the best writer in the world, but if you're writing something that they don't want to read that week or that is not very good, they'll just say, I'm not going to publish this, because they live and die by the readers liking what they're reading. So I'll conclude, as a scientific paper would conclude, by just summarizing my results. I believe that, theoretical physics and science fiction has some interesting parallels, although they're not the same. Science fiction does not predict the future. New ideas are central in physics, but they're not central in science fiction. You've got to watch your writing styles if you're going to do both. And I think scientists do have an advantage in writing science fiction, but it's not necessarily the ones that everyone believes. Okay, so it's 10 minutes till, and we'll stop for questions. I think it's a hybrid activity. I think it's clearly more art than science, but I think it's at the overlap between the two. I mean, I think it's the one of the areas where you kind of, can bridge the gap between arts and science. I mean, there are a lot of people out there writing musical performances to illustrate scientific topics. I think that's science with an art emphasis. I would put science in the art category. I mean, I'm not going to get money from the NSF to write science fiction. I don't think I'd get it from the NEH either, but I think it's in the art category. Okay, that's definitely science fiction. Well, I mean, oh, okay. Well, I think it's true. I mean, I always tell people when you write a proposal, it's a third of it is stuff that you already did, a third of it is stuff you're actually working on right now, and a third of it is stuff you think you're going to do, but you might never get to it. Proposals have to be more interesting than a scientific paper, but they can't be quite as breezy as a fiction story. Right. 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 I think it's there are in the modern physics teaching literature, there's a lot of concern over that. When I taught the first year course, I always liked, I guess I kind of taught it like a science fiction story. I always liked to come up with some demonstration that was wild and wacky and counterintuitive, and then explain how it worked at the end. And that's kind of a show and then tell sort of thing. But you're right. I mean, I think that in teaching, we end up, just because of time constraints, we have to tell. We can't really show, and they don't really get a sense of how any of these ideas develop. It's just kind of, given by the gods from on high. Yeah. Will I write something new? Or, oh, you mean like fantasy or? Well, I'm thinking of, I'm toying, since I've stepped down as chair, with writing a satirical novel about a physics department. But the problem with that is that the literary world is just full of academics writing about the academic world. I mean, I think mine would be funnier, but because it'd probably get me fired. But maybe when I Maybe I'll get the manuscript together, and then when I retire, I'll send it off to an agent. Yeah, it'd be exciting, wouldn't it? I think it depends on what you're trying to say. I mean, I have tried to get away from passive voice. You know, abstracts are where you see the passive voice. It is shown that, it is demonstrated that. I think if it doesn't get too chatty, it's okay. I mean, I think I've tried in my, writing scientific papers, I've tried to move away from the passive voice just because it sounds so clunky, but you also can't get all cutesy, and, the journal won't take it and people will think you're an idiot. So I try not to, you can't get too far away from the standard writing style or people will not approve.
Is there any science papers that you've written which you want to go back and present?
Oh yeah, absolutely. So the paper that I wrote on the time variation of pi is clearly that came out on April 1st in 2009. You can look it up.
Yeah, look it up. It's actually very, very fun.
It's on the archive, not in a referee journal.
Not yet.
I'm working on it.
Okay. Okay, so if not, let's thank
Thank you.